Hello students, welcome back to C programming. Today let us discuss operators in C programming. So coming to the operators, we have various operators in C. One is arithmetic operators. It could be plus, minus, star, forward slash, modulus. Relational operators, it could be less than, greater than, less than or equal to, greater than or equal to. Equality operator is double equals, which shows equal, equality, not equal to. This shows inequality. Logical operator, it could be ampersand, that is logical and, logical or, which is a pipe character, logical not. Unary operators could be unary minus, increment operator, decrement operator. Conditional operator, this is also called as ternary operator, which has a question mark. If this is true, this is the true alternative, else this is the false alternative. Then we have bitwise operators. In bitwise we have and, or, XOR, not. Assignment operator is equals. Comma operator, then we have the size of operator. So let's see the operators one by one. First let's see the arithmetic operators. The arithmetic operators are plus, minus, star, which shows multiplication, this is division, this gives the remainder. So let us consider one example. We have the variable declaration like this. Say integer a equals 10, b equals 5, and result is the variable which is going to hold the result. Let's see the arithmetic operations one by one. If we consider addition, the operator is plus. The syntax would be like this, a plus b. The result is a plus b, which is 10 plus 5. So the result of 10 plus 5 is 15, which is stored in the variable result. Now let us see the second operation, which is subtraction. The operator is minus, syntax is a minus b. So it is 10 minus 5, which is 5. This is 10 minus 5. This is 10 plus 5. Coming to multiplication, the operator is star. The syntax is a star b. Result of 10 into 5, which is equal to 50. Then we have the division operation. The operator is slash. Syntax is a slash b. Result is 10 by 5, which is equal to 2. Then we have the modulus operator. The operation is, it is going to give the remainder. The modulus operation, this is the operator. The syntax is a modulo b. Result is 10, when we divide 10 by 5, the remainder would be 0. So this is about the arithmetic operators. Next we have relational operators. So we have less than, greater than, less than or equal to, greater than or equal to. So this is, the operator is less than, the meaning is less than. Example, we take 3 less than 5. We are going to check 3 less than 5. If it is true, it gives a value 1. So the result would be either 0 or 1 when we check for the condition. Look for the next operator, which is greater than. Say you are going to check 7 greater than 9. Is 7 greater than 9? No, it is not. So it gives a value 0. Then we will see less than or equal to. So this means less than or equal to 100 less than or equal to 100. Either it is less or it is equal to 100. 100 is equal to 100. So, the condition is true. This gives a value 1. Then we have greater than or equal to. So, this means greater than or equal to 50 greater than or equal to 100. Is it true? 50 greater than 100? 50 greater than 100? No. 50 equal to 100? No. So, both the conditions are false. That is the reason it gives a 0. Next we have equality operators. So, this is not equal to, this is equal to. So, let us see one by one. Double equals means this is comparison operator. We are going to check whether, say for example, A equal to B. This is how we use this operator. This returns 1 if both operands are equal. Say if A equal to 5, B equal to 5. Then if I check if A equal to B. Okay. So, I have to write it up. So, let me take A equal to 5, B equal to 5. Say if I want to check if A equal to B. Now, A is 5, B is 5. So, both are equal. In this case, this returns a 1. Otherwise, it is going to return 0. Then, say for example, not equal to, A not equal to B. This is how we check, but here it is actually equal to. If A equal to 5, B equal to 5, this condition fails. So, returns 1 if operands do not have the same value. Otherwise, it is going to return 0. Here both are having same value, the condition fails. So, what it is going to return? It will return a 0. The next operators are logical operators. Under logical operators, we have logical AND, which is shown by double ampersand, logical OR, which is shown by double pipe symbol, logical NOT, which is shown by an exclamation mark. So, let us see them one by one. First, let us see logical AND. See, whenever there are two conditions, say for example, A greater than B, B greater than C. We have taken two conditions. If this is true, this would be 1. Say if this is true, this would be 1. If both are true, then this would give us a 1. So, for this we will have a truth table. There are two variables A and B. A is 0, B is 0. A and B would be 0. A is 0, B is 1. This also would be 0. This is 1, this is 0, this is again a 0. Both are 1. When both are 1, we have a 1. So, mean to say, when all the inputs are high, the output would be high. This is the AND operation. When all the inputs are 1, output would be 1. If any one of the input is 0, the output would be 0. So, that is about the logical AND operation. Next, we have logical OR operation. We will take an example here. Say for example, A greater than B, B greater than C. We are going to check for two conditions. If there is a OR symbol here, if this is true or this is true, the result would be true. So, when we consider the OR operation, if any one of the input is 1, the output would be 1. When all the inputs are 0, the output would be 0. So, sorry, this is OR. This is A or B. So, this is 0, 0 would be 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1. So, this is logical OR. Now, let us see logical NOT operation. So, we have integer A which is equal to some 10, we have B. So B is not of A. We are going to negate this A, then the result is assigned to B. So in case of this, the truth table would be like this. If the input is 0, output is 1, input is 1, output is 0. So anything, say for example, A is 10, whatever may be the value which is a non-zero value. So if this is a non-zero value, this would become a 0 value. If this is a 0 value, this would become a non-zero value. So integer A equal to 10. So we have A is a positive value, B would be 0. When you negate this not of A, this will become 0. So B would be equal to 0. This is about logical NOT operation. So now let's see unary operators. Under that, let us discuss unary minus. Say there is one integer variable A and B is also integer, it is holding the value 10. Say A is a integer, B is a integer, it is holding the value 10. So minus B is assigned to A. We are going to take the negative value of this B. B is 10 minus B, which is A. So A is going to get the value minus 10. So this is unary minus. Then we have increment operator. Here we have two variants, either it is prefix or postfix. Let's consider one example, integer x equal to 10. So we have a location, say x, and we have a location y. X is 10. I am going to use post increment here. So in this case, I will assign the value of x is going to get y. So the value of x is assigned to y like this. After that, the value of x is incremented. So whatever is there in x will be stored in y. Y gets 10. Then x is incremented, x becomes 11. X becomes 11. So this is post increment. Let us look at this example. Say for example, x is 10 plus plus x. So first I will increment x. This is pre-increment. First I will increment x. X will become 11. That 11 is stored to y. So y will get 11. In this case, y got 10, here y is going to get 11. So it is equivalent to, first we are incrementing x, x gets x plus 1. The value of new x is saved to y, or it is stored in y. So this is how the pre-increment and post-increment works. This is post-increment, this is pre-increment. Now let's see the decrement operator, minus minus. Even here we have two variants. One is prefix, the other one is postfix. We call it as pre-decrement and post-decrement. Let's take the same example. Say we have x, we have a y. X is initially 10. Okay. So x minus minus, y equal to x minus minus. It means x is stored in y. X is stored in y. Y gets 10. After that, we are going to decrement x. X becomes 9. So this is equivalent to the value of x is stored in y, and then we are going to decrement x as we have shown here. This is post decrement. Now let's see pre-decrement. Let's see pre-decrement. Let me take x as 10 itself. Say I have x which is 10 and then I have a y. Here I am going to decrement x first, x minus minus, so x becomes 9. Then the resultant value is stored in y, y gets 9. So this is equivalent to first x is decremented by 1, 10 becomes 10 minus 1 which is 9. Then the new value of x which is 9 is stored in y. So y gets a value 9. Now let's see what is a conditional operator. So conditional operator is also known as a ternary operator. The syntax goes like this. Expression 1, there is a question mark. If the condition is true, this is the true alternative. There is a colon, then we have the false alternative. So then a semicolon. So we are going to check for a condition. If the condition is true, we are going to execute the true alternative. If the condition is false, we are going to execute the false alternative. So let's take an example. A greater than B. So we are going to check if A is greater than B. There is a question mark. If this condition is true, the value in A is assigned to the variable large. If this condition is false, the value in B is assigned to large. So whatever is the evaluation of this ternary operator, that result is stored in this variable large. Now let's take a second example. There is an integer a equals 5, a is 5, b is 3, c is 7. So out of the three values, we have to take the smallest value. So we have the ternary operator. What is a? A is 5, 5 less than 3, the condition. Is 5 less than 3? No, 5 is not less than 3. So this is the true alternative, this is the false alternative. So 5 less than 3 fails, we have to go for the false alternative. So we will have to execute this. B less than C. So 3 less than 7. Is 3 less than 7? Yes, it is less. So B, what is the value in B? 3. This is going to give 3. So A less than B, we have come here. 3 will be stored in small. So small is going to get 3. This is how the ternary operator works. Now let's see the bitwise operators. In bitwise operators, the operation is performed in bits. The truth table remains to be the same as logical AND. Let's take an example. Integer a equals 6, b is 10. Say a is 6 is 0, 1, 1, 0. B is 1, 0, 1, 0. This is 10. So we have to do C equals A ampersand B. So what is C? C is 0 and 0. This is 0. 1 and 1 is 1. 1 and 0, 0. 0 and 1 is 0. So this would be the result of bitwise AND. Now we have bitwise OR operation. It is the same. So A is 6. 6 is 0, 1, 1, 0. B is 1, 0, 1, 0. The result is C. C, which is equal to, it is OR. The truth table remains to be the same as logical OR. So this is 0, 0 would be 0, 1 is 1, 1 or 0 is 1, 0 or 1 is 1. So the result is 1, 1, 1, 0. This is bitwise OR. Now let's see bitwise XOR. So for this bitwise XOR, these two are the inputs. A and B are the inputs and this is the output. The symbol is the caret symbol. This symbol. We are going to use caret for this. The inputs are same 0, 0, 0, 1, 1, 0, 1, 1. If both the inputs are 0, the output is 0. If both the inputs are 1, the output is 0 again. In other cases, the output is 1. So this is how the XOR works. Now we have to take an example. Integer A is 0, 1, 1, 0. This is 6. B is 10, which is 1, 0, 1, 0. The result C would be 0, 1, it is 1, 1, 0, 1, 1, 1 is 0, 0, 0 is 0. So this is the result we are going to get in bitwise XOR. Now bitwise NOT operation. It performs logical negation on each bit of the operand. It actually produces the ones complement of the given binary value. Say for example 0, 1, 1, 0. If this is the given binary value, it is going to do the ones complement, which would be equal to 0 becomes 1, 1 becomes 0, 1 becomes 0. This is the result. So this is bitwise NOT operation. So bitwise operations cannot be applied for float or double variables. This is one precaution which we have to take. Then we have assignment operators. So we have this equals, plus equals. So this is equals, this is assignment, plus equals. When we write this, there is no gap between the plus and equals. Same way minus equals, there is no gap between these two. Then star equals, slash equals, modulo equals. So all these are the assignment operators. Now we will see one example, integer x. So I have declared a variable of type integer, x equals 10. So the assignment is always from right to left. The value 10 is stored in x. This is what it means. Now let's see one more example. This is x. So this is y. We have sum. We have three variables of type integer. X is 2, y is 3. Sum is initially 0. Then x plus y. So this is 2 plus 3. The result is stored in sum. So sum will get a value 5. Any variable at any instance can hold only one single value. So whenever a new value comes, the old value is overwritten. This we will have to know. Now the assignment operator has right associativity. Say for example, I have A equals B equals C equals 10. So how does it work? Say A equals B equals C equals 10. First 10 is stored in C. Then this value is stored in B. After that the result, that is 10 is stored in A. So this happens first, then this happens, then this happens. That is why I have shown it with the parenthesis. So C equal to 10. This happens first. The value 10 is stored in C. This 10 is stored in B now. After that the same 10 is stored in A. So after executing this line, all the variables A, B, C, all the three variables will be holding a value 10. So now let's see comma operator. Integer A equals 2. So it means A is a variable of type integer and it is been initialized with 2. So, this is A, this is B and we have x. A is 2, B is 3, x is 0. So, we have a comma operator which is going to separate the different variables. A equal to 2, comma, B equal to 3, comma, x equal to 0, semicolon. So, when we have to separate multiple variables, we use the comma operator. Now, let us see one example here. X equal to plus A, comma, B plus equal to A. So, what is x going to get? First, we will increment A. So, A is actually 2, this A becomes 3. Then, B plus equal to A, it means B equal to B plus A. That is, the value is incremented, B equal to B plus equal to A means B equal to B plus A. So, B and A are added, the result is stored back in B. So, B is 3, A is 3, 3 plus 3 is stored in 6. 3 plus 3 is stored in 6. So, now x is going to get 6. The resultant value is x. X is going to get 6. Next, we have the size of operator. So, the syntax is like this. Size of, we have open parenthesis, closed parenthesis. Let us see how this can be used. I have integer a equal to 10, unsigned int, some result. Size of A is of type int. So, if int consumes 2 bytes, then result would be 2. If I say size of char consumes 1 byte, so the result would be 1. If I say size of int, it would be, if integer consumes 2 bytes, the result would be 2. If I say size of float, if float consumes 4 bytes, the result would be 4. So, that is about the size of operator. Now, let us see the operator precedence. If it is a parenthesis, then the braces, then dot. This dot is used when we use the structure. This we use when we use the linked list. So, all this is from left to right. Postfix, that is auto increment, auto decrement, this is right to left. If it is prefix, right to left. Even the unary operator, negation operator, indirection, address, size of, type, everything is from right to left. Then star slash modulo, this is left to right. Plus minus, again left to right. These are the bitwise operator, that is left shift, right shift. This is left to right. Then less than or equal to, greater than or equal to. These are the relational operators. This is again left to right. Equality operators, left to right. Ampersand, left to right. Caret, left to right. Or, left to right. And, or, left to right. Ternary operator, right to left. And all these assignment operators, it is again right to left. Comma operator is left to right. So, this is about the operator precedence. Thank you.